Hi and welcome to week 2 of our Pac-Man series, where we try and recreate Pac-Man as much as we can. Just managing expectations. We're not looking at completely doing the whole game with the title screen, etc. But we're looking at doing the core gameplay of Pac-Man. So what we've done so far, last week we were able to create the map, we were able to create the little pieces of food, and we have a kind of little bit of a working Pac-Man to go around the board, although no collision detection, and he's not really lined up correctly. So we kind of need to sort that out today. The first thing I really want to focus on is where he's going to be, and then we'll try and figure out his movement. Now, the key to Pac-Man's movement, as we all know, is that he carries on going. And so what we're probably going to do is have some sort of way of having a direction that the player taps on being saved as a value that is just always going to be followed by the Pac-Man on the screen. So if I'm, for instance, if Pac-Man's here and he's moving this way and I press an up arrow, say here, then he will know to go up here, and then he's continually going. So it might be easier if I just sort of show a video of Pac-Man. Let's see whether I can find one. Right, so you can see here, he will just keep going until he stops. And so when my fingers are off it, he just stops. He will just keep going until he stops. There we go. And I'm going to just shut this up. For those interested, I did just die on it. But it's really important that we know what the game is that we're trying to recreate and just see what the movement is. So the movement is that Pac-Man will carry on until he stops. So we need to figure out a way of programming that in today's episode. So first things first, we said we would try and calculate where Pac-Man starts. So opening the Excel spreadsheet, he starts in the middle here. And so that is 23 tiles down? So it'd be 23 times 24. So it'd be 552. So let's put that in first. So we need to have like an at start. Start a frame. We want to create. Do we want to create or just use the one that's already there? Might use the one that's already there. And position the y coordinate to be 552, which is what we calculated that to be. And then we need the x coordinate, which we can calculate. So we've done this before. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 times 24 is 312. So what I'm going to do is I'm going to type in x coordinate. So position x coordinate. We're going to do 312 plus, and then what we probably want to do is make him so that he's in the middle. And so to get him in the middle, we've got to work out, actually, I'll tell you what, I'm just going to do 313 for now. We've got to work out what width he is. So did we make him 30? Can't even remember. What width did we make him? I think we made him 40. So we'd need it to be 20. So we'd need to add 20. And you might think, well, why don't I just write 332? Well, because I know that I can change this. If I've mucked up somewhere, I can change this. And actually I probably have mucked up. So each tile is 24. So in total there will be a width of 48 for those two. And he is 40 wide. So it would be +4, wouldn't it? Some logic there somewhere. Let's see whether I'm right. No, failed completely because his action point thingy-bob, not his action point, the other one, is in the middle. So actually I just need to add the 24. That I don't need to know his width at all because his action point's in the middle. So we're just going to plus 24 to that and then we need him halfway down on the Y. So it will be, this should be time. What? Hang on. Click the wrong one. Right. And then this will be plus half of his height. Hopefully this will work. Looks a bit low. If I get rid of that, does that work? Oh, I need it to be 5 plus 12. Does that make any difference? Yeah, it does. Okay, yeah, that makes sense. So we've got a nice starting position there. So that's where he should be started. And what I can do now is I can have a counter, and it's always good to show the counters. But one of the problems we have is that our background is black. So there's two ways around this, because if I put a counter down, we won't be able to show it, right? It will just be black. So what I can do is I can put a background object. I think quick backdrop works. And I can change the color of it. I think I can double click. Is that? No, I think you've got to go into it and make it white. And so I can have my kind of data store here, which will show all the values. And I'm going to store his current direction. So the direction that the user has put in for him in there. And so I'm going to get rid of all of these, although actually I don't want to get rid of all of them. I want to delete just the fact that we're moving him. So I want to keep the direction changes, because that's quite useful. So I could do that all with the counter. And so when he's going right, I'm going to set that counter to 1. And I've got to figure out this logically. I'm going to set the counter to 2 for down. Left will be 3. And then up will be 4. And then stationary will be 0. So let's order these more logically. So down, left, and up. And so let's just play it here. So clicking right, down, left, up. Perfect. And so now we've got a store of what direction he needs to be walking in. But we don't want him to necessarily be walking in that direction if there's an obstacle in the way. We actually want it just to reset it. No, not going to happen. So we need to keep track of where Pac-Man is in relation to everything else. And that is going to be easier said than done. And we will use the array object we've created earlier, because we can know straight away whether Pac-Man can move left or not using that array object. So let's have a look. So let's just play this and try and figure this out. So we need Pac-Man. So let's just focus on the right hand movement. So every time there's a 1, we need Pac-Man to just keep going to the right. So what I can do is I can say that every 10th of a second, move Pac-Man, or position Pac-Man, just right 1 pixel. But only if the direction, which is our counter here, is equal to 1. So let's run it. If I click right, we can see that's really slow, so we need to speed that up a bit. So we'll make it every 100th first of all. Click right. Still quite slow, so to make it quicker, what we can do is instead of adding 1 pixel, add 2 pixels, make it twice as quick. I think that speed's all right. And you can see that he'll just keep going on and on and on. Okay. So we need some way of telling whether Pac-Man's about to hit a collision or whether. And you can see I can stop him by pressing any other direction, which is good. But we need some way of telling whether this is a good idea or not. And we need to have it in the condition here, because we don't want him to move at all if the next pixel will be overlapping the background. So what might be sensible is to add a condition. So insert, and we're just going to compare two general values. Now, this is going to get fiddly here. So we need the position of we need to look up in our array read value from X, Y, and Z, and we need to somehow figure out where Pac-Man is in our array. So this is our array of values here. Pac-Man's currently in the middle of between here, and we need to figure out where Pac-Man is in the array. Okay, this is going to get quite complicated quite quickly. So we could first of all figure out and I'm not going to get this right straight away, the X position and the Y position of Pac-Man. And we can divide that by, is it 24? So this will be our first point. And we need that equal to 32, because 32 was the area where Pac-Man can go. I don't think this will work, but we shall see. So I'm going to click right. Wow. Okay, that got a lot closer than I thought it would. I'm pretty impressed with that, actually, to be honest. That's really good. So the issue is that he's gone a little bit too close to the wall there. And the reason is that rounding. And what I want to do is I want to go into this condition, and I think I want to floor it. And what floor does is whenever you divide things, you're going to have decimals or floats or whatever you want to choose to call them. And what we want to do is we want to round it down, because then it shows the threshold of him crossing into that zone. It will be the floored version. So floor rounds everything down. So 3.5 would round down to 3, 3.8 would round down to 3. Everything gets rounded down to the nearest integer. So, and this is probably one of those times where I tell you all this stuff and it's not the solution, but we shall see. I can't really remember where floor is. Is it in string or number rounding or something? It's in one of these ones somewhere. Calculations. There we are, floor value. Like, I just remember the fact that you just type in floor and it will do it. There we go. Now, hopefully, fingers crossed it will work now. Who knows? And it's still the same problem. Why? Okay, I can also tell that I think this was actually flooring it anyway. So the solution I had was not the right solution. The issue is that the position of Pac-Man is based on the center of Pac-Man. And so we put the action point in the center. So we've got to subtract 20. So it's the position, and we're going to take away 20 from that position. And actually I floored, so I didn't floor the right thing anyway. I only floored the, oh no, that's fine. Yeah, because I only floored the X value. So maybe this is doubly good, who knows? We'll see. Oh, interesting. So it's not working at all now. So I think that my issue was, don't know. Maybe I shouldn't subtract the 20 then. Maybe I solved this before. I just didn't know it. No, I didn't solve it before. Not quite sure what's going on with this. So what I'm going to do is I'm just going to keep going and pretend that it's all hunky-dory. And then hopefully the issue will find itself. So I'm going to do the down thing now. And what I've done is I've done the floor, but it's not quite lining up. So we'll configure that out later. And yeah, this time we're going to move the so position of the Y coordinate will be the current Y position, and then we go -2 because we're going down. Let's see whether this works. So I'm going to go right and then down. Yeah, interesting. So it's not going down at the moment. So I'm going to copy and paste this one, and we're going to have a look at left and see whereabouts that goes. And this is really common in troubleshooting this. These kind of issues come up all the time when I'm working with movement in. So I can see we can go right and left quite easily. And interestingly, it stops there, and then it almost gets into problems because of, I think because of the up and down. There's some issue there, and same with here. If I go here, it again then gets stuck and it can't go anywhere, which is not going to be ideal, because the whole point of us doing our own movement is because the Clickteam movement will do this. It will kind of Pac-Man will get stuck somewhere if we just do an 8 movement and collision detection. So we need to probably think up a different way with this. So what I'm going to do is pause it and try and think up a solution to this. Alright, so what I've done is I've created a kind of debugger here, which shows the X and Y coordinate. And it shows the calculation I've done to figure out whether Pac-Man can move. And it was just quite quickly I realised the mistake. The mistake is that if Pac-Man reaches a point where he can't go, then obviously he's reached that point, so you will not move, and the calculations here are all the same. It's like, no, stop Pac-Man at that point. So we need to look ahead. We need this to look one move ahead, and so what we're going to do is create a global variable, and we're going to do this early on. And I think the global, I have no idea where they're stored. There we are. And we're going to call this speed. And oh, hang on, we can't call that. Okay. Let's call it pack speed. Pack speed. There are some protected variable names in Clickteam. And we're going to put it as 2. And the reason for that is that when we do the movement, we just put in 2. But we're going to be coding a lot more stuff. And so what we want to do is make sure that if we decide that 2 is too quick or too slow, we can just update it one place and it will update them all. And the reason for that as well is because we need to look at where the next tile is. So if we were to add the 2 to this, will it be safe? Will it collide? If it will, stop. And we need to do for each of these. So if we go down 2, if we go to the left 2, and then obviously if we go up, so this will be 4, and it will be if we go up 2. I've got that the wrong way around. Obviously down is we add. As I mentioned, I think in a previous video, right? And we'll need to nope. Need to add. I think I got that wrong in the last one, right? So hopefully, this works really well. Perfect. And let's see whether we can go up. can go up. So one of the issues here is that you can kind of go up and down, which is not what we want. We want one defined track around this, so that will be something we need to look at improving. But you can see here the collision, the walls are definitely stopping Pac-Man, which is interesting. So that's pretty cool. So it is working. It is working. Also for this debugger, just show you, I've done an always event, and if I just click in there, then you can see what I've done there. I've just literally spat out the values so that I could see what was going on. And as soon as I did that, I did have to change these to single quotes, otherwise Clickteam would get confused. But that is where I'm going to stop today. I've promised you movement of Pac-Man, and we've got movement of Pac-Man, but we're going to have to improve it, because this Pac-Man, let's just show you, this Pac-Man should not be able to go up and down here. That is not a desirable mechanic for movement. So tomorrow, hopefully, we'll sort that out and try and find maybe a tighter way of controlling Pac-Man's movement. We want him to just be able to not move up and down if the corridor doesn't allow it. And we will also be hopefully eating the food along the way, because then it will look more like Pac-Man at that point. Thank you very much. Keep the comments coming in. I pre-record these, so sadly I've not seen any of your comments yet. But I look forward to reading them. If you've got any ideas for future videos, please send them my way. Click the like. It really does help motivate me to share my thoughts on these games and make these videos. Although I make them for me, but it's always nice when comments come in. So thank you very much. See you later. Bye.